Okay, this is a review of simplifying radicals, which will be coming up on our final because this was a most missed part of the recent test. So let's look at these different parts of each radical. So we've got here the index, this little value here. Go ahead and label it. We've got the radical, the actual square root symbol. And we've got the inside term, which is our big base of x. So what if I want to represent a square root? I'm going to do the square root symbol with no index because it's just implied. If I want a cubed root, I'm going to put a little 3. If I want a fourth root, I use the symbol like that. If I want a fifth root, I use the symbol like that. Okay, let's go take a peek at these down here. So square root, there is an index of 2 in this one, means I'm looking for groups of 2. So I can shortcut this into things like this, like break it up into groups of 2. This answer is going to be 10x squared. But what we've done in class is we've broken this down into the smallest parts, where 100 is 10 times 10. And then you guys broke it down into 5 times 2 times 5 times 2, and then stretch out that x to the fourth, and then look for the groups of 2. And so circling our pairs, I see a pair of 5s, a 5 comes out. I see a pair of 2s, a 2 comes out. I see an x and another x, so x squared. Actually, let me just stretch that out. And then there's nothing left in the radical if everything gets used up, if everything has a partner. And so my final answer is just 10x squared. Next one is the square root of 36 and the square root of 88 to the 6th. So think of it like this. Isn't just the square root of 36 just 6? But if we break it down the way we've been doing, and then square root of 2 times 3, 2 times 3, and we're going to be looking for the pair of 2s and the pair of 3s. And then a to the 6. And why are we looking for groups of 2? Because it is a square root. All right, so final answer is a 3 comes out, a 2 comes out, an a, another a, another a. It's going to be 6a to the third as my final answer. This one, we're just looking for a group of 3, and so my answer is just 5. This one, we're looking for a group of 4, so the answer is just 2. Next one, we're looking for groups of 3. And by the way, I'm doing Tia's method. I'm doing the stretch out expanded method. But you could do this with Tehani's way with dividing. So here we're going to have a y that comes out and a z that comes out and a z that comes out. But could you do it like this? Y to the 3/3, z to the 6/3. So my final answer is just y z squared, whichever way you look at it. Which way do you like better? Do you like dividing Tehani's way? All right, fourth root. Okay, looking for groups of 4. An s cubed comes out, and a t squared comes out. Final answer. Fifth root of 1 is just going to be 1. Fifth root of 32 is just 2. Cubed root of a -8. Did you realize that odd indexes can actually yield a negative result? Okay, now we're getting into some practice. So this was like the going over the rules again. So pause the video here and try this practice. Let's see how you do. Okay, let's check in. And by the way, since it's negative, all these have little negatives. Notice that the exponent becomes the numerator and the index becomes the denominator. That could be rewritten as the first power, but you get what I'm saying? It's just a negative x. And you can do these Tia's way. You can do this stretching these out and circling the groups of 4, stretching this out and circling the groups of 6, whichever method works best for you. Remember, we can split up this radical. This is 3 times 3 times 3. This is 2 times 2 times 2. So there's my final result. 7th root. It's an odd index, so we're going to have, it is possible to take a 7th root of negative 2. And so I've got a group of p squareds, a group of negative 2, and there's nothing left inside.